Welcome to the session on the FHIR SQL Builder. I think you're going to find this session useful if you're interested in FHIR analytics. We will be discussing a very new feature still under development for Iris for Health. My name is Patrick Jameson. I'm the product manager for Iris for Health. And I will be discussing a new product feature of Iris for Health, which eventually will be offered in a new cloud service. I would like to acknowledge the many developers, engineers, and managers that have contributed to this presentation, and look forward to your feedback and suggestions as we roll out this new feature in an early access program. Here's my agenda. We're going to spend a little time on FHIR analytics and why it's important, how this new feature in Iris for Health called the FHIR SQL Builder makes it possible to do analytics on FHIR data simply and easily, how you can become an early adopter for this preview feature. Here are a few benefits you'll receive from this presentation. You'll have a better understanding of how to extend your knowledge of analytics to FHIR and learn how to create a custom SQL schema from your own FHIR repository. Well, we all know that FHIR is the future. It's an open API specification. It mainly uses JSON, although it can use XML for exchanging healthcare data. It offers better interoperability, especially better semantic interoperability. We see that its adoption is growing all over the world, especially in the United States and Great Britain because of mandates by the government. In the United States by the Office for the National Coordinator and CMS. FHIR is also extensible, so with that, I believe that it's poised for future growth and will encompass numerous future use cases. So who wants to use FHIR analytics? Well, if you're capturing FHIR data, you're probably thinking about how you could do analytics with this data. Providers are probably the first major audience for driving all kinds of quality improvement projects using FHIR data. However, a number of companies in life sciences, such as medical device companies, pharmaceutical companies, and insurance companies also would like to do analytics with FHIR data. There are an enormous number of use cases, and this is just a partial sample, for things like population health, managing risk in populations, reporting on the quality and cost of population care, for example, in public health, surveillance in the age of COVID. Data sets can be produced that are anonymized for research. We could also use FHIR data for machine learning models doing predictive analytics like predictions of sepsis or readmission prediction, and using it as HEDIS measures for, again, measuring the quality of care. So you're probably thinking to yourself, why can't I just do analytics with FHIR data? The problem is simple. FHIR is a complex directed graph. It is not relational. Special methods need to be employed to make it possible to do analytics with FHIR data. So let me show you a very small portion of a FHIR graph with an anchoring FHIR patient resource, patient named Ida Brown. You can see that she has a couple of observation resources pointing to her, smoking status and blood pressure. She has a link going out to a general practitioner, and that general practitioner has an outward link to an organization. All of this is depicted in a nice graphic format, but it's hardly relational. So how would you analyze it? And then when we get to something more real, where we have a lot of information on a particular patient or group of patients, with lots of conditions, diagnoses, observations, and encounters, well, it becomes a very messy problem indeed. When you look at the individual FHIR resources, they form a tree. So this is what you see. Notice that the elements in this tree are frequently objects themselves, and these objects can contain arrays or other embedded objects. So this is a pretty complex structure, and again, it is not relational. Normally, those structures are expressed as a JSON string, so that we could post this resource, for example, in the JSON in the body of a FHIR message. So how are people doing analytics with FHIR data today? Well, there are a number of approaches. I'm just going to outline a few of the major approaches. Microsoft employs a type of projection based on dot-based navigation. What developers need to do if they want to use Microsoft's approach is create what's called a YAML definition file. They don't use FHIR path expressions per se. One of the aspects of this approach is that you need to be a developer and hopefully have a pretty good insight of what's in your FHIR repository, because otherwise building that YAML definition file is not going to be easy. With the YAML mapping file, you can project the data or copy it to a SQL structure and use their business intelligence tools such as Power BI. Google has a different approach. They first copy the FHIR data to their analytic repository, BigQuery. They could then query the data by making extensions to ANSI SQL. For example, there's a special operator called unnest, so they could take arrays embedded in FHIR elements and parse them into a single row for each element in the array. They also use a special open source syntax called SQL on FHIR. So here is an example of an aggregate query that uses SQL on FHIR. Notice that you have a type of navigation using the dot operator, so we have value dot quantity dot value, but we need to unnest an array or an object, and here is an example of that syntax. Naturally, you can't use your normal business intelligence tools, and you need to train your business analyst to understand these operators to have any hope of doing any kind of FHIR analytics. So what is our vision? Well, we wanted to make this much easier to do. Our goal was to create a sophisticated projection tool to help developers create a custom SQL projection of their FHIR repository data and transform it without needing to move the data out of their FHIR repository, making this a very scalable solution. We wanted the data analyst and business intelligence developers to work with FHIR using the tools they already understood, so they wouldn't have to learn YAML or unnest operators. So here were our top design goals. We wanted a data steward to be firmly in control of building these SQL projections, making all the selections, transformations, and other projections of SQL to SQL. We wanted to employ an easy-to-use GUI to make this possible so that anyone with modest skills could make SQL projections of their FHIR data. And we wanted to allow for the creation of multiple schemas, knowing that individuals have different use cases and that no one SQL schema could ever satisfy all data analysts or all use cases. So how do you make that best SQL projection? Well, we think there's a few things you need to understand. First, what you need to do is help the user understand what is in their FHIR repository in the first place. There's no point in projecting information that doesn't even exist in the repository. You need to have a tool that helps the user create custom mappings between elements and columns in the projection. And so you want to do this without having to create a complex programming language. And you want to have a way to map things so that you could use different names that might make it easier in the SQL projection. There are times where you may want to create parent and child tables that are related. And so you want to be able to index those columns in those tables to make it easy to do SQL queries. So let me show you the steps on how this is done. We first analyze your FHIR repository, and we report back all of the resources and elements in the repositories that you might want to project to SQL. We obtain from the user their actual selections and mappings to different column names when that is the case, and we then generate definitions in a file that does the actual projection. We also have the ability to run maintenance scripts so the later changes in those definitions can be easily added. So here's an example. On the left side, you see we have a FHIR resource that we're going to project into a SQL table on the right. Notice the ID column we're just projecting pretty much without changing it, but with the ID identifier of the patient, we're projecting the value that you see here into a column called MRN. Now we could do all of this because of the unique capability of IRIS to do multi-model projections of data. IRIS is a high-performance multi-model database, and it's ideally suited to the task of making these SQL projections. In the next few minutes, I'm going to actually do a live demonstration. I'm going to show you how you could use a GUI to develop what's called a transformation specification. So you won't need to write YAML. You'll be basically selecting from FHIR elements and building on the lower panel tables and columns that will project that data. The net result is you'll be able to use the familiar tools in IRIS and our business intelligence tools the way you've always used them to do analysis. So I'm going to show you a demo of this. I want to remind you this is pre-release functionality, so it's likely to change in minor ways. We're at a stage now that we are launching an early adopter program where we want to get your feedback before we finally lock down the exact features of this new enhancement to IRIS. I'm going to log into the management portal as a data steward. And the first thing I'm going to do is perform a new analysis. So I'm going to select the FHIR repository to analyze. I've already set this up as demo. And I'm going to get 4,000 unique values, and I'm going to get 100% of all records. Then just simply launch my analysis task. Now this takes a few minutes depending on the size of the repository. It could take many hours. I'm speeding this up just for the sake of time here. As you can see, it's accumulating statistics as the percentage of resources analyzed. And now we're at 100% so that we can now see the analysis that it performed. So I'm going to go to our transform spec, and I'm going to create a new one based on this analysis. So first thing I'm going to do is select the analysis, and I'm going to give it a name. And here I'm going to call it FHIR SQL 2. And I'm going to create that transform specification. So I'm going to edit it. I'm going to do a real simple transformation. I'm going to take a patient resource in our repository, and I want to select a few different fields here. So I'm going to select the ID, the gender. I'm going to include that. Save it. Birth date. I want to include that in my schema. And notice I can have multiple birth Boolean or integer. I'm going to just do the Boolean true or false here. And deceased date time, I'm going to save that. And as you can see, we're building up our currently selected schema on the bottom here. So I have a transform spec. Now I'd like to basically project that as SQL. So I'll go back to my home page and create this data projection. I'm going to set up this transfer task, my demo repository, and my FHIR SQL spec, transform spec 2. And I'm going to create a package for all of these tables in FHIR SQL 2. I'll keep the package name the same as my transform spec name. I'm going to update that. And now I'm ready to look at this. I'm just going to come over to the management portal. I'm going to filter my tables by FHIR SQL 2, that package. And you can see I have a patient table. That table was generated. It's a projection. I'm going to just drag it over, and we'll execute on it. And we'll see it has exactly those columns that I selected, the resource ID, birth date, etc. So now, what if I wanted to create and modify that spec? I could do that as well. So I can take that transform spec, and now I'm going to go back and I'm going to make some minor edits. In this case, I just want to add the address, which is an array, and I'm going to add this as a child table. I'll make this very simple. I'll just call this address, and I'm going to select the city. In the future versions, we'll have defaults for these, but right now I'm typing them in, what the column names are. Of course, you can make the column names anything you want, and that's part of the beauty of transforming these things, but they will have defaults. So that is done. Now I could go back to the home page again, and in this case, all I need to do is update that, and I can now link this directly to the management portal, and I could just take a look, and you now see I have this new address table that was projected. And you could see there's an internal ID just for our use, but you could see that you could get the city, country, it's linked to the patient table. Well, I hope you enjoyed this brief demo, and it gives you a glimpse of the power of a FHIR SQL Builder. I'd like to encourage you now to join the Early Access program. If you're interested, please write me at patrick.jameson@intersystems.com, and I'll send you information as soon as the program's available. And if you need any other information, please reach out to me or my colleague Carmen Logue, and we'd be happy to talk to you about analytics on FHIR. Thank you very much, and enjoy doing analytics on FHIR data.